All right, let's jump right into it. Welcome to today's explainer, where we're breaking down the complete industrial guide to VFD faults and troubleshooting. Look, whether you're a BE or diploma student, an electrician, a technician, a maintenance or automation engineer, or a PLC programmer, this explainer is built exactly for you. We're going to unpack some pretty complex concepts today, things like variable frequency drives, faults, alarms, and AC motor protection, and we're going to make them crystal clear. So picture this. You're on the floor and your VFD suddenly trips. Does it just throw up a random fault code or completely stop the motor without absolutely any warning? If you work in an industrial setting, you already know how incredibly frustrating that is. Sudden plant shutdowns cost serious time and, well, a lot of money. But hey, here's the good news. VFD faults are actually super common, and if you can just accurately identify the root cause, you can easily troubleshoot and fix the vast majority of these issues. Truly, mastering these fault codes, that's your superpower on the factory floor. Okay, here's our roadmap for today. We're going to cover the symptoms, fault detection, common faults, troubleshooting, prevention and monitoring, and finally wrap up with DEVI automation. Let's get to it. Section 1, the symptoms. Let's quickly diagnose the absolute basics of VFD protection. Right off the bat, there's a crucial distinction between two things that constantly confuse people: an alarm versus a fault. So an alarm is really just a warning. It's an indication. It's basically the VFD tapping you on the shoulder saying, hey, something's slightly off here. You might want to look at this. Crucially, the machine keeps running. A fault, on the other hand, is a critical trip or shutdown. The VFD literally cuts the power to protect your equipment. Specifically, it's protecting the AC motor and the internal IGBT, which is the insulated gate bipolar transistor. That fault protection is absolutely essential because it stops catastrophic hardware damage dead in its tracks. Section 2, the diagnosis. How exactly do VFDs even detect these problems in the first place? You can think of the VFD like a doctor that is continuously checking the vital signs of your machine. It all starts with the power supply feeding into the VFD controller. From there, the drive does this real-time continuous monitoring. It's checking the voltage, it's checking the current, it's feeling out the internal temperature, and it's tracking the motor's overall performance. If absolutely any of these parameters cross over a safe threshold, boom, we hit step 4, fault detection. This immediately triggers that protective trip or an alarm. It's just this continuous, high-speed loop of protection. Moving right along to section 3, the culprits. Let's identify the specific illnesses, the common VFD faults. When you walk up to the display on a tripped drive, you're almost always going to see an abbreviation. Here are the most frequent culprits you'll run into out in the field. You've got overvoltage, or OV, and undervoltage, UV. You'll see overcurrent, OC, and motor overload, OL. Then we have overtemperature, OH, and ground fault, GF. You also might stumble across phase loss, short circuits, communication faults, encoder faults for vector drives, external faults, or in some cases, internal CPU faults. Let's zero in on two of the biggest offenders, overvoltage and overcurrent. The really key thing to remember here is that overvoltage, or OV, very often happens during deceleration. See, when a motor slows down too quickly, it basically acts like a generator. It sends power right back into the VFD and spikes the voltage. Overcurrent, or OC, well, that's a different beast entirely. That's usually caused by a short circuit, wrong parameters, a cable fault, a physical motor jam, or, honestly, just way too heavy of a mechanical load being applied all at once. Next up, we have undervoltage and motor overload. These are great because they point you in opposite directions. Undervoltage, or UV, points backward to your power source. It tells you there's a low supply voltage, maybe a loose connection, a general power failure, or some issue back at the MCC, the Motor Control Center panel. Motor overload, or OL, on the other hand, points forward to the mechanics. It triggers when you've got a consistently high load, a mechanical jam, bad bearings that are adding friction, wrong motor parameters in the drive, or a serious cooling problem happening in the motor itself. And look, in today's highly connected factories, we absolutely cannot ignore the communication fault. This happens when that invisible digital handshake between your devices just drops. We're talking about your RS-485 network, Modbus RTU, or Ethernet connections. Basically, when your PLC or SCADA system disconnects from the VFD, this is the fault that pops up. And you know what's crazy? The root causes are usually so simple, but wildly frustrating. A wrong address setting, an incorrect baud rate, or literally just poor physical network cabling. All right, section 4, the treatment. Let's take all this theory and turn it into actionable step-by-step troubleshooting. Okay, your drive just tripped. What's your first move? First, check the fault code on the display. And please, I know it's tempting, but do not just hit reset. Write the code down. Next, consult the user manual. I can't stress this enough. Every manufacturer uses specific subcodes, so that manual is your absolute best friend. After that, grab your multimeter and measure the supply voltage coming into the drive to ensure it's stable. Then, check the motor current using a clamp meter to see if that motor is pulling more amps than it's actually rated for. Keeping that checklist going. Next, you want to verify all your wiring. Look for loose connections or damaged insulation. Then, dive into the VFD parameters. Did someone accidentally mess with the acceleration time or the motor nameplate data? It happens. After that, physically analyze the load condition. Is a conveyor jammed up? Is a pump blocked? Finally, and only after you've verified everything is completely safe, go ahead and perform a trail run. To really lock this in, let's look at some real-world industrial case studies. Think about a water pump. It frequently experiences a motor overload, or OL, if debris clogs up the impeller. A conveyor belt, notorious for overcurrent, OC faults, especially when too much product is suddenly dumped onto it. Industrial fans very often trigger overvoltage, OV faults, if they're allowed to coast to a stop too fast. Compressors, working in super hot environments, are incredibly prone to overtemperature, OH faults. And in highly automated spots, like the textile industry, communication faults happen all the time, simply because heavy machine vibration physically disrupts the network cables. Section 5. The prevention. How do we stop fixing broken things and actually start preventing them? Proper maintenance is a total game changer. It drastically reduces VFD downtime. Your absolute must-do list includes ensuring proper earthing to prevent ground faults, using correctly sized shielded cables to block out electrical noise, verifying correct parameter settings, and doing periodic tightening of all electrical terminals, because vibration will loosen them over time, guaranteed. Also, make sure you have excellent panel cooling so the VFD doesn't overheat, regularly check motor health, and literally always keep a backup of your VFD parameters. And all of this builds so beautifully into modern automation. Here's your automated data flow. The motor's performance is read directly by the VFD. The VFD shoots that data over to the Programmable Logic Controller, or PLC. The PLC then pushes it to the HMI screen right there on the factory floor, and all the way up to the SCADA system in the control room. If a fault occurs, that SCADA system instantly pings an alarm notification straight to the maintenance team's phones or dashboards. Having this fault history and remote monitoring capability completely transforms how engineers manage plant uptime. Finally, Section 6, the solution provider. Let me introduce you to the industry partner that can help you actually solve all these complex challenges. DEVI Automation Solutions is essentially your comprehensive partner for the future of industry. They offer a huge array of services. We're talking industrial automation, PLC programming, HMI development, and full SCADA systems. They're absolute experts in implementing variable frequency drives, integrating artificial intelligence, and getting your facility set up with the Industrial Internet of Things, or IIoT. From smart manufacturing and smart agriculture to home automation, solar energy solutions, control panel design, engineering projects, and even technical training, DEVI Automation Solutions brings the smart technology and powerful solutions you need for a better tomorrow. So, as we wrap up this explainer, I want to leave you with a question to really chew on. How will you optimize your plant's maintenance to reduce downtime and boost productivity today? Understanding these VFD faults is a massive first step. If you found this explainer helpful, please go ahead and hit that like button, comment your thoughts or questions down below, and don't forget to subscribe to the DEVI Automation Solutions YouTube channel for more deep dives into industrial tech. For any business inquiries, you can reach out to them directly. Until next time, stay curious and keep optimizing.